Somewhere around a campfire, tens of thousands of years ago, a piece of burnt wood rolled out of the flames and left a black smear across a rock. Nobody in that moment knew it, but that single accident would eventually lead to something bigger than fire itself. It would lead to the invention of memory outside the human brain. Because before ink existed, every idea, every story, every piece of knowledge a person had could only live in one place, inside their own head. And when that person died, the knowledge often died with them. Ink changed that forever. But here's the strange part. Ink wasn't invented. Not really. Nobody sat down and designed it on purpose. It was discovered by accident over and over again in different corners of the world, by people who weren't even trying to write anything at all. So how did burnt sticks and crushed rocks turn into the substance that would carry human civilization forward? And why did it take thousands of years before anyone realized what they'd actually found? To understand this, we have to go back to a time before writing existed at all. Around 40,000 years ago, early humans were already leaving marks behind. Not letters, not words, just marks. Handprints on cave walls, rough outlines of bison and horses. Deep in caves like Lascaux in France and Sulawesi in Indonesia, people were mixing charcoal, ash, and animal fat into thick, dark pastes and pressing them onto stone. They weren't trying to invent a writing system. They were probably trying to tell a story, mark a hunt, or maybe just leave proof that they existed. But without knowing it, they had already stumbled onto the two basic ingredients that ink still uses today: a dark pigment and something to make it stick. That was the background. The real story, the one that leads to actual ink, starts thousands of years later in two very different parts of the world, almost at the same time. Around 2500 BCE in ancient Egypt, scribes had a problem. Egyptian society was expanding fast. Trade records, religious texts, royal decrees, all of it needed to be written down and kept. Carving hieroglyphs into stone worked for temples and tombs, but it was slow, expensive, and impossible to carry around. Egypt needed something faster. At the same time, in ancient China, a similar problem was building. As the early Chinese dynasties grew more complex, officials needed a way to record laws, taxes, and history, and stone tablets simply couldn't keep up with the pace of a growing civilization. Two civilizations, two different problems. And remarkably, two almost identical accidental solutions. In Egypt, scribes noticed something about the black soot that collected above their oil lamps and cooking fires. It was fine, it was dark, and when it was scraped off and mixed with water, it created a thin black liquid. On its own, that liquid was useless. It would just smear and wash away. But when someone added a natural gum, likely from the acacia tree, something changed. The soot particles bonded to the gum, and the gum bonded to papyrus fibers. Suddenly, the marks didn't wash away. They stayed. At almost the same moment in history on the other side of the world, Chinese artisans were discovering the same basic trick, but with a twist that would go on to influence writing culture for thousands of years. Instead of scraping soot from lamps, Chinese ink makers began deliberately burning pine wood and oil in controlled conditions, collecting the fine soot that rose from the smoke. This soot, mixed with animal glue, was then pressed into solid ink sticks. To use it, a scribe would grind the stick against a stone slab with a few drops of water, slowly releasing the black pigment. What both civilizations had done, without any contact with each other, was solve the exact same problem in the exact same way. Soot for pigment, a natural binder to hold it, water to activate it. But here's where the story gets more interesting, because this accidental discovery wasn't just a lucky one-time event. It happened again and again because the ingredients for ink weren't rare or exotic. They were everywhere. Think about it. Fire produces soot. Soot is dark and fine. Nearly every early civilization that used fire for cooking, lighting, or ceremony would have noticed the black residue it left behind. The real breakthrough wasn't discovering soot. It was figuring out how to make it stick to a surface without smearing away. And that single technical problem, how to bind pigment to a surface, became one of the most repeated aha moments in early human history. In India, ink makers experimented with burnt bones, tar, and even burnt husks to create a similar black pigment known as massie. In Mesoamerica, later civilizations like the Maya developed their own carbon-based ink using soot mixed with plant-based binders, allowing them to create the intricate bark paper books known as codices. Each civilization arrived at a strikingly similar solution, not because they copied each other, but because they were all working with the same raw materials nature provided: fire, ash, water, and plant resin. This wasn't one invention, it was one solution being discovered independently, again and again, whenever a civilization reached the point where memory needed to outlive the human mind. But there was still a problem. Carbon-based ink, the soot and gum kind used in Egypt and China, had a weakness. It sat on top of the writing surface rather than soaking into it. Over time, especially in humid conditions, it could smudge, flake, or wash away entirely. If civilization was going to trust ink with its most important records, it needed something more permanent. The solution to that problem wouldn't arrive for thousands of years, and when it did, it came from an entirely different, almost poetic accident. Sometime around the early centuries CE, in the Mediterranean and Middle Eastern world, someone noticed something strange happening to the bark of oak trees. Certain trees were covered in strange round growths, small, hard lumps that almost looked like fruit but weren't. These growths, now known as oak galls, were actually caused by tiny wasps laying eggs inside the tree bark. The tree's chemical response to the wasp created these bulging galls, rich in a compound called tannic acid. A history doesn't record exactly who, crushed these galls and mixed the extract with iron. And when they did, something unexpected happened. The mixture reacted chemically, turning a strange blue-black color as it dried, and unlike carbon ink, it didn't just sit on the surface. It actually bonded into the fibers of parchment and paper. It couldn't be wiped away. This new formula, iron gall ink, would go on to become the dominant writing ink across Europe and the Middle East for the next 1,400 years. It's the ink used to write the Magna Carta. It's the ink Leonardo da Vinci used to sketch his inventions. It's even the ink Beethoven used to compose his symphonies. But it also had a hidden flaw, one that scientists only fully understood centuries later. Because iron gall ink is chemically acidic over long periods of time, it can actually eat through the very paper it's written on. Some of history's most treasured documents are today slowly being damaged by the ink used to preserve them. Conservators and chemists are still working to stabilize these documents, using techniques rooted in modern materials science. The very substance that let humanity finally write things down permanently was quietly working against permanence the entire time. So what's the real answer here? How did ancient humans accidentally discover ink? The truth is, ink wasn't discovered once. It was discovered independently, multiple times across multiple civilizations, because every fire that humans lit produced the raw material for it: soot from flames, resin from trees, tannins from tree galls. These weren't rare materials hidden in some remote location. They were the accidental byproducts of everyday life. Cooking, burning oil lamps, trees defending themselves from insects. Humans didn't invent ink from nothing. They noticed patterns in the mess that fire and nature left behind, and slowly, through trial and error across thousands of years, they learned to turn that mess into meaning. What changed history wasn't the soot itself. It was the moment someone realized that a smear of black residue could hold an idea in place long after the person who made it was gone. And that idea, using a simple accident of chemistry to defeat forgetting, didn't stop with ink. Because once humans learned to trap pigment onto a page, we were only one step away from a much bigger question. How did we learn to trap it into permanent, reproducible words at all? The invention of the alphabet itself? That story is even stranger than this one. If you enjoy exploring the biggest questions about history, science, and how our world came to be, consider subscribing to this channel for more documentaries like this one.